Hello and welcome to the 2018 ActualTech Media Converged, Hyperconverged, and Composable Infrastructure EcoCast event on today, Wednesday, December 12th, 2018. My name is David Davis, and I'm excited to be your moderator for today's event. On today's event, we're excited to be joined by Pure Storage, Pivot 3, and Robin Systems. Before we jump into today's event, let me tell you how this is going to work. Each presenter has 20 minutes to explain how their solution can solve your technology challenges. And after that presentation, I'll be asking the presenters live questions from you, our audience. So we want this to be an educational event. Keep your questions coming in. Use the questions box there on your console as much as you'd like, and I'll be asking the best questions live. We at ActualTech Media created the EcoCast and MegaCast event series to help technology professionals such as yourself learn about the most innovative enterprise technology solutions available to you today, to help you to do it in one online virtual event to get all your questions answered, and while you're doing it, have a chance to win some very cool prizes too. I'll be talking more about those prizes and the legal requirements on how to be eligible for the prize drawings in just a moment. I want to make sure that you're aware of the questions and answers panel right there on your audience console. If you see that panel, go ahead and take a moment to just type in the one thing that you hope to learn on today's event. Go ahead and just put that in there, and I'll be sharing that with today's presenters, and we'll be taking that as feedback for future events. So go ahead and just type that in right now. I'll be answering every one of those to the best of my ability. Now, during the event, I'll also be asking you some questions. I'll be asking you some poll questions. You answer those poll questions in the slides window where you're watching this presentation right now, and I'll be sharing the results of those poll questions with you. We want this to be a social event. I'll be monitoring the hashtag for today's event over on Twitter. That is HCI EcoCast. I'll remind you of that in just a moment. And finally, today's presenters have selected some resources for you. Those are on the Handouts tab, which is right next to the Questions and Answers panel. So just click on the word Handouts on your console, and you can download those PDF assets, share them with your friends, family. They make great gifts for the holidays. So today we have 3 Amazon $500 gift cards. I'll be giving one of those out after each of today's presentations. To be eligible for the prize drawings, you must be on the live event. If you're watching this on demand, the prize drawings have already occurred. Winners have the option to make a donation to a selected charity. For the full legal prize terms and conditions, go to your Handouts tab there in your console and scroll to the bottom where it says Prize Terms and Conditions. That'll bring up a website with everything that you need to know. Now, through the MegaCast and EcoCast event series, we've donated thousands of dollars to our selected charities, thanks to generous attendees who win prizes and then choose to donate those to charity. We'd love to help you donate to charity if you'd like to do that. Thank you very much in advance. Now, I said we want this to be a social event. Again, the Twitter hashtag is HCI EcoCast. I'll be following that throughout the event. Today's event is produced by ActualTech Media. You can follow us on Twitter for the latest on our events and innovative enterprise technology solutions. And of course, you can follow me on Twitter as well, David M. Davis. If your profile says you have anything to do with technology or maybe coffee, I'll follow you back as well. Now, before we go, I want to remind you that your console is kind of like a windowed operating system in your web browser. So any of the windows that you see in there, you can drag around. If you click on the title bar, if you go to the edge of the window, you can resize it, you can minimize it, you can maximize the slides window. So I encourage you to rearrange your console so that you can best see the questions as well as the slides throughout the event. Now, this is a live event. I also want to remind you, and things can and sometimes do go wrong. Hopefully today will be a perfect event, but if you have any trouble, if you can't hear, if you can't see, if things just aren't working, push refresh on your web browser, and 99% of the time that will resolve any problem. If a refresh does not solve it, feel free to post a question in the questions box with your tech issue, and I will do my best to solve it. And with that, it's my pleasure to introduce today's keynote speaker. That is the CEO of ActualTech Media, also known as Mr. Hyperconvergence, Scott Lowe. Take it away, Scott.
Thank you for joining ActualTech Media for our final EcoCast of 2018. It's been a great year, and we thank our entire audience for joining us for so many great events this year. On this final EcoCast, we want to talk about a topic that has really been at top of mind for a lot of IT leaders and practitioners for a number of years now. And it's this idea around integrated systems. And that's a category of systems that includes converged, hyperconverged, and composable systems. But where did these originate? Converged has been around for quite a while, hyperconverged a little bit newer, and composable is a little bit newer. But these really all stem from our foray into cloud. Now, not directly, but when we talk about cloud in the terms of hyperconverged and these other integrated systems, really we're thinking about the outcomes you get with cloud. Cloud changed more than just cloud. There were a lot of things that happened when organizations started to adopt the public cloud that really had an impact also on the on-premises environments that we all operate. Number one, it made us rethink how we actually manage these environments, how we pay for these environments, how we scale these environments, and how we view these environments in terms of how they support the workload that the enterprise demands. But most importantly, what we saw was this idea that IT can be, at least on the surface, simple. Now, I'm a big believer in the phrase that the more simple something appears, the more complex it really is. If you look at something like an iPhone, it is a very deceptively simple device, but it has incredible power underneath the hood. And I think the same is true for a lot of the emerging architectural options that we're seeing in the enterprise data center today, including composable, hyperconverged, and converged systems that I'll be talking about here shortly. Simplicity is king when it comes to these systems. And that doesn't mean they want these things to be dead simple so anybody can just run them. That's not the purpose. The purpose is that they're simple so that the enterprise can move forward without having to be bogged down by what have often turned into complex IT projects because of the complexity associated with the infrastructure we're trying to support. But what are these integrated systems? So I've got a list here of three types. We have converged, hyperconverged, and composable. So a converged system is really a loose aggregation of hardware, software, and a management layer. And on the event today, we have Pure Storage. We'll be talking about their converged solution. But this is a little bit more, this is a system that's a little bit more simple to manage than your legacy environment. And the reason is because we're basically bringing together a bunch of solutions into one manageable resource. So we're going to bring the storage in, we're going to bring the servers in, we're going to bring a hypervisor, maybe the networking layer and things like that. And it's not necessarily one single resource, but we're going to manage them as a common element. And that's really where the power of converged infrastructure comes into play. So the other thing it provides us as we look at how these things compare to one another is converged infrastructure allows us a great deal of resource flexibility. So basically, it doesn't really matter how much storage you have versus how much compute you have versus whatever else. If you look at something like hyperconverged, at least in its original form, we really have this linear scalability thing going on that I'll talk about shortly. Now, one of the things we see with converged is there's often more than one vendor involved, and that's the case with Pure, who has a partnership with CISCO. Now, there are solutions out there that are single vendor. They're not necessarily better or worse in some cases than others. But when you start to think about this idea that you can get solutions from multiple vendors and bring them together, then you can start to think about a best-of-breed approach that doesn't have the best-of-breed downsides that we've seen with some of our traditional infrastructure environments. And by those downsides, I mean cost and complexity and integration, making sure all this stuff actually works together. A converged infrastructure is almost, in fact it is, really sort of a reference architecture that's been incredibly well tested and then productized and sold. And that is really important because it allows you to make sure that what you're buying actually works well for your use case, and it's a solid investment in your data center. We see a lot of people using these sorts of environments to implement huge consolidation projects. There's no more need to have servers strewn about the country. You can bring them all into a single rack or a single, maybe a single data center or racks of servers, and really undertake what could be massive consolidation projects for your on-premises workloads. And the most important thing here is it enables a great deal of simplicity that we don't get always when we start to think about legacy constructs. When we think about hyperconverged infrastructure, it really started as a simple combination of hypervisors, servers, and storage. Basically, what happened was vendors abstracted these resources into software-defined resources, which they already were in some cases. If you think about the compute layer in a hypervisor-based environment, that was already software-defined servers. What got added in hyperconvergence was the software-defined storage capability that really has defined the technology. And, as we look at the market, though, some people see these as necessarily being configured to meet the needs of specific applications, and they kind of look down on hyperconverged in some cases. Not as much anymore as they used to. In fact, not nearly as much anymore, particularly as we've seen hyperconverged really come into its own. And I'm going to talk about where we are and where we're going with hyperconverged shortly. But what you saw from hyperconverged in 2012 is a far cry from what we're seeing from hyperconverged in 2018. It's moved from being a technology to a platform, and that's a critical distinction we'll discuss. But there were some pros and cons. If we think about the pros of hyperconverged infrastructure, the really key thing is the simplicity angle, like we saw with converged. This allows us to do far easier management of our workloads than we really could do in a legacy environment. And it gave us, most importantly, a new way to scale for the masses. So it used to be hard to grow environments, especially storage environments, especially when you start to think about where we max our storage and things like that. When we start to think about hyperconverged scenarios, as we add more nodes, we're simply linearly scaling the environment. If you need more RAM, if you need more compute, or if you need more storage, you simply add another node. And it's that simple. Once you add a node, all of the resources from that node are then consumed by the cluster, and those resources are then made available to workloads running inside that cluster as they're needed, as the administrator configures them. And that was incredibly beneficial to original hyperconverged solutions. Now on the downside, that's a great scaling methodology, but some people consider resource inefficiency at scale to be a challenge. So if you really don't need more storage capacity, you just need more compute, or vice versa, you have to add both at the same time. What we've seen, though, is that current vendors in this space have pretty much solved that problem. There's sufficient resource configurability on new nodes that you don't have to waste a bunch of resources like you did in the past. And that's a good thing. And some have talked about in the past about eventual networking constraints as you scale these to a certain point. All of these nodes are brought together with at 1 gig in very rare cases, or a 10 gig network more commonly. But when we think about networking, there's also 25 gig, 40 gig, 100 gig networking capability. So I don't see the network as necessarily the bottleneck as we look at scaling hyperconverged environments, because I see the capability and the potential for Ethernet to continue to keep up with what's happening in the world. One of the other problems with hyperconverged, though, has traditionally been there's no focus on networking. Compute and storage are first-class citizens in a hyperconverged environment. Networking has often been an afterthought, and security and things like that. That is changing. Today, I don't know of a hyperconverged vendor that's not looking at doing something with networking and or security and things like that. They are all looking at this problem and looking at what they can do to help make the networking piece easier or help make the security piece easier that so many organizations demand. And as we look at the next step, really beyond hyperconvergence, we have composable infrastructure. And this is something that's relatively new. It was a term coined by, I believe, HPE a couple of years ago. And it's really intended to be a sort of a meta term for what's next. What are we going to do when we have to sort of conglomerate, hyperconverged and converged, but we still have to support bare metal and all this good stuff. So really, what happens if you throw all your resources, compute, storage, and networking, into a huge software-defined bowl? Well, you get the ability to dynamically provision new workloads on demand. So basically, as you need to create new workloads, support new workloads, you can create the workload operating environments that those workloads need by stitching together all of the resources that you already have. And you get eminent resource flexibility from a composable environment. And what this allows you to do is, as you need more storage, you add more storage. As you need more compute, you add more compute. It becomes that simple in a composable environment. So it sort of in some ways takes a step beyond hyperconverged, but I think that there's a hugely blurring line between hyperconvergence and composable today, and actually composable and converged, and I'll talk about in a second, that really wasn't there before. Because as converged and hyperconverged solutions have become more capable, they've really started to add some of the things that we see that are being supported in a composable environment. So the idea in a composable environment is everything is disaggregated, which is very different than when you think about hyperconverged, which everything is aggregated. So all of the resources are disaggregated, and you get the ability to compose an aggregation on demand. So, and that's really kind of powerful when you start to think about how flexible enterprise IT has to be as we move in more deeply into an era of digital transformation. So what's changing? Well, let's start with Converged. One of the things that's really been interesting is, if we look at a number of years ago, 10 years ago, Converged was on the scene. It was really expensive, and it was good, but it was really expensive. Today, really, rather than having these expensive behemoths, we have very affordable systems that are far more capable than those early forays into the market. One of the original benefits that was considered a benefit of converged systems was the fact you had one throat to choke. So you had these single vendor systems that were brought together, even if they were conglomerations of products from different vendors, that were a single phone call away for support. But you didn't have as much resource flexibility as you do today. And you couldn't necessarily as easily swap out the storage from another vendor. To a certain extent you could, but that's changing dramatically. Today, we see all kinds of converged solutions where the components can be swapped out, and you're looking at true best-of-breed opportunities when it comes to supporting individual resources. So we get a lot of capability that we didn't necessarily have 10 years ago. And if we look at the changing face of hyperconverged infrastructure, we're seeing massive, really, evolution and revolution in some cases in what's happening here. If we look at one of the vendors on today's event, Pivot 3, they were one of the first vendors, or the first vendor, to introduce a full NVMe data path to the environment. If we look at Robin Systems, who's also on today's event, they've provided a hyperconverged Kubernetes platform that is an industry first. So there are all kinds of things happening in the world of hyperconverged. It's expanding and in some ways fracturing a little bit, not in a bad way, but it's really becoming a market where there is a solution for just about every need that's out there. Now, we're also seeing lots of other things happen, like some introduction of resource disaggregation and hyperconverged, where we're splitting storage and compute and allowing those to scale individually, but still be managed as a singular entity. And we're still calling that hyperconverged. There are things like that happening in the market, and we really have to think about hyperconverged more as a management mentality rather than the underlying inputs that are going into it. Over the years, we've had to really rethink how we define hyperconverged infrastructure to meet the morphing needs of what we're seeing in the market, or the changes we're seeing in the market. And I think that's going to be something that continues on well into the future. And I think it's powerful and important that we continue to see these sorts of evolutionary things happening. The other thing we're seeing is hyperconvergence is becoming more of a platform. We're seeing, networking brought into the platform. We're seeing lots of other things happening. Like I said before, we're seeing containers brought into the platform through Kubernetes and all that good stuff with companies like Robin Systems. And we see innovators like our friends Pivot 3 that are on the call today, constantly improving the platform to meet even the needs of even more demanding workloads. Things that we couldn't have even really dreamed of supporting just a few years ago are eminently supportable today in ways that we couldn't have imagined. And I thank you for watching this keynote, and I hope you enjoy the rest of the event. Thank you so much.
Hey, it's my pleasure now to introduce Mr. Colin Gallagher, Director of Product Marketing at Pure Storage, and Marcel Schwager, who is a Global Alliance Manager at CISCO. Colin, Marcel, are you with me?
Yeah, we are.
Yes,
Thanks.
sir.
Awesome. Take it away.
Thanks, David. So good morning, good afternoon, good evening. I know we have a global audience here tonight, so thank you all for joining. As David had said, my name is Marcel Schwager, and I am the Pure Storage Global Alliance Manager at CISCO. So quickly, I'm just going to take you through an overview of the Cisco Pure partnership, a brief tidbit on the infrastructure market, and I will introduce FLASHSTACK, and then I'm going to turn it over to Colin so that he can do a quick deep dive on one of the more new and exciting use cases we have for FLASHSTACK. So something that's not on this timeline that I always really like to highlight is that Pure was founded in 2009. And so when you look across the storage market, Pure's pretty uniquely positioned because the storage market is really dominated by players who have been in the industry for the last 10, 15, 20 years. Pure being new to the market allowed them to take a different approach. I like to describe it as revolutionary versus evolutionary. So instead of having to evolve on technology that storage companies were selling at the time and evolving on that technology, Pure was able to come in with the revolutionary approach and basically take flash storage and make it the de facto storage standard. And they built Pure Storage on three key tenets, right? Simplicity, performance, and software first. That's a really unique value prop to CISCO, because CISCO kind of took the exact same approach when we introduced CISCO UCS into the market. So in 2015, after Pure went public and IPO'd, we were so happy to announce the marrying of these two companies and introducing FLASHSTACK into the market. Fast forward 4 years later, FLASHSTACK now has over 14 CISCO validated designs. We have thousands and thousands of global customers, and we are really in all facets of the market, from enterprise applications. We also have one of the most complete private cloud offerings in the market. And something that's on the docket that I'm excited to kind of tease today is that we'll also have a purpose-built artificial intelligence reference architecture coming out in the very near future. So this is a slide I always kind of like to tease at the beginning of a digital transformation conversation, because I think it really resonates to everyone out in the crowd. I know that everyone probably resonates to one of these companies, whether it be Amazon, Lyft, Airbnb, Google. And what they've really been able to do is take what we would now look at as what was an antiquated industry and completely revolutionize it by digitizing it, simplifying it, and providing absolute the best customer experience in the industry. And while it's easy to look at these companies now and say, man, their service offering is so simplistic, we all know that the path to digitization for all of these companies was extremely difficult. And when all of the industry analysts across the board, from Forrester, Gartner, IDC, really look at what are some of the biggest issues that IT leaders or leaders in general have with digital transformation, consistently they boil up 4 key issues. The first is around continuous innovation. I think that a lot of companies look at digital transformation as a technological rip and replace of infrastructure. But at the end of the day, digital transformation is just as much of a culture shift as it is as a technological shift. The second issue is that IT infrastructure, IT functions need to stop looking at themselves and stop acting as what I would call cost center, and really look at themselves as a service provider. And IT really needs to leverage their ability and their strategic position near the applications and near the data to provide net new value add back into the organization. And again, not just be looked at as a cost center. The third issue that I think companies really need to navigate throughout the digital transformation is this idea of on-prem or cloud or both. 10 years ago, everyone would say every enterprise application is going to live within your own firewall on your own data center. 5 years ago, the hype was that everything's moving to public cloud. And I think today we figured out what that equilibrium looks like, that we'll have some applications that live on-prem, some applications that live in the cloud, and some applications that live both places. And then finally, the last tenet or the last challenge of digital transformation is really around merging old technology with new technology. And as companies grow and new technology comes out, you're going to have to figure out how to integrate the old and the new. I think really speaking of figuring out how to converge old and the new, I'm sure that this looks very familiar to everyone out there. And it's really around, as a company grows, oftentimes their data islands and their data silos grow as well. And it's really just a function of organic growth of the company. As new applications are added, as new users come to your company, you'll continue to scale out your storage infrastructure, and eventually you'll have 5, 6 different islands that you're having to manage. And what happens is you end up spending more time managing each one of these data infrastructures than really unlocking the gold mine that's sitting underneath each of these data islands or these data silos. Understanding that value or that gold mine that's underneath each of these infrastructure is really what drove us to create FLASHSTACK. What FLASHSTACK does is it merges all of those data silos under a stateless CISCO UCS compute platform, and it combines it with Cisco's bread and butter networking, Nexus and MDS with Pure's all-flash storage into one complete infrastructure that really does four things for a company. It simplifies a company's operations and it brings it under one management platform. It eliminates those data silos so that you spend more time managing one infrastructure or one platform instead of 5 or 6 silos across the company. It allows you to scale with agility. And finally, it allows you to put that value back into the business, and it allows IT organizations to act as a service instead of a function. And so for those of you who really don't know, and I'm sure most of you have seen this slide before, but there's really 3 things to FLASHSTACK. And we kind of talk about it as the 3 legs to a stool within the data center. And for that stool to work as it should, each one of those legs need to be the same length and functioning at the same speed. And so we break it down as there's compute, network, and storage. In the past, CISCO has been able to bring that state-of-the-art compute and network. And now that we've teamed up with Pure Storage, we can deliver across the board the most high-performance infrastructure in the market. I'm going to kind of just jet through these next 3 slides, but I can sum it up in a couple sentences. Over the last couple years, or actually, what we've done to validate the success we've had over the last couple of years is Cisco and Pure hired IDC to be a third-party validation engine to really look into the market, talk to our customers, and prove out the stats that we know we can deliver in one key study. So this slide really talks about how one of our customers saw actually 15% higher developer productivity, and they were able to deliver $1 million back into the business by taking that productivity and focusing on other activities. And this slide talks about how one of our customers was able to basically, going back to that silo slide, they're basically able to combine all those data silos into one management layer and manage all their core infrastructure under one application or one lens. And because they're able to simplify the management layer, they're able to put that time and effort back into other places in their business, in this case, security. And finally, the next slide on IDC, I think is the most powerful one, is that IDC looked across over 5 years and validated that compared to another infrastructure platform in the market, customers were able to see 46% lower TCO over a 5-year period, which is just absolutely astounding. And finally, my last slide before I hand it off to Mr. Colin Gallagher is that although we're one of the newer players in the market, FLASHSTACK has been validated on just about every major workload that you could be running in your infrastructure. And at this point, I'm going to turn it over to Colin so that he can double click on one of those workloads and talk about one of the more new and exciting solutions we have for our platform. Take it away, Colin.
Thanks, Marcel. I'm going to talk a little bit FLASHSTACK for Oracle, one of those particular use cases, talk about it in a little bit more detail, and then give a customer example. Marcel talked a lot about silos, and one of the key benefits of FLASHSTACK is really helping eliminate silos. The irony is that data warehousing is an ideal place for consolidation. And you may be saying, well, isn't the data warehouse the place where you consolidate everything? The reality is that today we have more silos in data warehouse than ever before. Really depending on your application, your infrastructure vendor, there are several different silos you can be using, everything from Teradata to Netezza to IBM to Oracle Exadata. Every vendor positions their own data warehouse appliance for their particular applications, really preventing you from being able to consolidate data across all these platforms, and more importantly, preventing you from being able to share it across all these platforms. So let's take a look at the challenges of data warehouse appliances. In this case, the example I'm going to give you today is really focused on Oracle, but a lot of this applies across any data warehouse appliance. You have 3 challenges. The first, and they're sort of chained together. The first is degrading performance. You sized your appliance 5 years ago when you first bought it. It was sized with the type of workloads you were doing then. Your data has grown, your compute needs have grown maybe, and your total performance for any individual workload has declined because you're now spreading that horsepower across even more workloads. So what you do, which brings us to the second problem, is you go and you add capability to your appliance. But because appliances are an appliance, you get fixed ratios of compute and storage. So if you just need more compute power, you generally have to buy additional storage to go with it. If you just need additional storage capability, you have to buy additional compute power, something you may not need. So as we would say, you're overpaying for something you don't need. And lastly, as I mentioned in the previous slide, these data warehouse appliances tend to be vendor specific. So in the case of an Oracle Exadata solution, it's really optimized for sharing your data with Oracle. Makes it much harder to share your data for other analytics applications that really need to leverage that data in the data warehouse, things like Hadoop, Spark, TensorFlow, or anything else. So to solve these problems, we recently announced a new FlashStack with FlashBLADE for, really optimized for modernizing Oracle data warehouse. Previously, our FlashStack solutions that Marcel had mentioned were built around our block storage product from Pure Storage, our Flash Array. We have added the capability to deploy it with FlashBLADE as well. And what FlashBLADE does is really delivers massively parallel storage for file and object, really allowing us to deliver industry-leading performance for Oracle databases. But again, because it's file and object, it can be easily extensible to modern analytics and AI. And it's fully validated by CISCO Pure Storage, like all of our FlashStack solutions. Let me double click a little bit on the key value prop, and Marcel mentioned this before, which is this really elastic scale capability powered by the stateless nature of both the storage and the compute capabilities. So as you need to add capability, either if you want to add block capability or file capability, depending on the storage type you've chosen from us, you can do it very simply. You can easily add a single blade with our FlashBLADE to get additional storage capability, and you can add nodes one at a time to get additional compute capability. So again, you buy what you need at the point in time you need it, maybe with a little bit of buffer, and then you slowly add additional capability as your needs grow throughout time. And if they don't grow, you haven't bought something that you're not going to need 3, 4, 5 years down the road. But let's take a look at this, how FlashStack has solved an actual customer problem and what it meant both in terms of capability performance and in terms of cost. So we have a large telecom customer in Asia who was using Oracle Exadata. They had, their license was expiring in 2017, and they were looking at upgrading Oracle Exadata. They were looking at the cloud. They rejected the cloud solution because the security wanted them to keep all the data on-prem. And they looked at other solutions in the market like FlashStack. They ended up choosing FlashStack. I'm going to show you the next couple of slides and clicks about why. So from a performance capability in 2013, they had sized their appliance for 50 ETL jobs. They were running about 6, and they had some spare capability. And they were doing their jobs in about 6 hours a night. By 2017, the workloads had doubled to over 100 ETL jobs, and it was now taking over 9 hours for them to, in some cases 10 hours for the reports to complete. And they had a 9-hour SLA, so they were missing SLAs for some of these workloads, or even in some cases all of them. So when they chose FlashStack, they actually saw a significant decrease because of that massive parallel flash performance down to just over 3 hours. And they have plenty of capability to add, so they can still meet the 9 hours, even if they double, triple their workloads going forward. They were also doing database backups as well. It took them 16 hours to do a full database backup. By the time they were running off at the end of their release in 2017, when they implemented FlashStack with FlashBLADE, it got down to just over 2 hours. So they saw some pretty incredible performance capabilities by implementing FlashStack. They delivered a better user experience as well. But the question you may ask is, what does it cost, right? We've delivered some generally impressive performance numbers here. The next question is always, what does it cost? How much am I going to pay more? Well, some surprising news there. They actually ended up paying less, not only less than they would have if they had stayed on-prem with Oracle Exadata, $9 million less, so to speak, but they actually paid less. The total solution cost them $3.9 million, and their original on-prem solution with Exadata cost them $4.2 million. So they're able to return cash to the business that way, and it was a relatively significant advantage. And there's some data that we can dive into here about how they managed to save this money. It really has to do with the total database licenses, the storage licenses. You do see here that the CapEx cost went up a little bit, but the storage licensing costs went down because they were able to leverage some existing storage, and they did not have to pay any more to license their database costs. That's the key difference between the on-prem X7 solution and the FlashStack solution. because they didn't require any additional compute capability. They're able to keep their core licenses flat. So we have documented the solution in a Cisco validated design. It's a pre-designed and pre-validated solution for workloads. Really allows you to have a turnkey solution to build that all-flash performance for faster query analytics, to allow you to do that massive consolidation of local databases, deliver increased developer productivity, as you saw from Marcel earlier, and as hopefully you saw from me right now, lower cost. So in summary, I just want to tie up quickly before we run out of time. A couple key takeaways I want to leave you with. FlashBlade really delivers industry-leading throughput, IOPS latency, and cooling, up to 20% less space and 10% less power and cooling. Tremendous amount of scale in a small form factor. It's really built and goes well with the stateless nature of UCS and tied all together with Cisco networking. When you use FlashBlade and Oracle, you can deliver fast read bandwidth. You can improve the speed of your data processing and scanning, as I just showed you. And lastly, you can lower your costs versus if you decide to stay on-prem or in the cloud. So there's no lock-in with the solution. We give you the choice of how you want to deploy it. If you want to move off to another solution in the future, you haven't been locked into a vendor. You can use and move your data. You can move to a different disaggregated system as you see fit. Now let's take some time for questions.
All right, great presentation. Great presentation, Colin and Marcel. I have popped up a poll question for those out there in the audience. I'm just going to leave that up while we do some Q&A here. The question on your screen is, how many people work in your IT department? Colin, thanks for being on the event today.
No, my pleasure. Thanks. I was happy to do this.
So we do have some questions here for you from the audience. Let's see. First, there was a comment that came in. Edward said, really like the FLASHSTACK approach. That's great to hear. Another question came in here, and they're asking, why are companies really struggling with digital transformation, in your opinion?
I think it's because, again, the challenges that Marcel mentioned, that they kind of think they try and bite off more than they can do at once, rather than seeing it kind of as a gradual incremental approach. It's not, it's not you're going to flip a switch and tomorrow you're going to be digitally transformed, but it's a sort of a never-ending journey. And so I think the companies that I've seen that do it well, bite it off and manage the chunks and sort of, do it in a variety of never-ending stages. And those who try and go, do too much too quickly tend to struggle, and some of them even fail. Yeah, I think that's kind of the best approach is to do it kind of at a measured pace.
Okay. Yeah, great advice. Great advice. Let's see, another question here. Can I use a third-party management or orchestration suite with FlashStack, and does that improve management of it?
Absolutely. I think, while both Pure and Cisco provide great management experiences, I'm both UCS director and Intersight on the Cisco side, and obviously with our Pure One cloud-based management on the Pure side, we recognize that buying a product is not, should not force you to change your management style. You've invested in management tools, training, processes, procedures, et cetera. And so we support something like 30 different APIs and management tools and orchestration tools for you to be able to manage your, FlashStack your way. So yes, you'll get the same great experience. Both of us have API first approaches to management, and that really allows you to integrate into what you're already doing to manage the rest of your infrastructure.
Okay, very nice. And then another question here, what is a validated design, and I'll follow on with that. Why is a validated design so important?
A Cisco validated design is a tested reference architecture that Cisco builds and tests in their labs to prove that it's going to work to support, the correct number of users, the right performance, whatever is stated in that design. It makes it very easy for our partners and customers to build solutions that to achieve a certain business goal. So if they want to deploy a VDI solution for 500 users, running on Zen Desktop, there is a VDI reference architecture for that tells you how to do that, quickly and easily to assemble the components, so you don't have to do all of that individual sizing and testing yourself.
Okay, and then is it possible?
It's all about predictable outcomes. Sorry. Go ahead.
Yeah, absolutely. Yeah, in IT we really need predictable outcomes.
Yes,
that's always very important. So, and then is it possible to pay for FlashStack with OpEx?
Absolutely. FlashStack is the only fully certified, stack that you can get through CISCO OpenPay, which allows you to pay for, in an OpEx model, you pay for a certain amount of capacity, then the rest, in CapEx, and the rest you pay for an OpEx if and when you use it, and if you don't use it, you don't pay for it.
Okay. Very nice. Very nice. There's a few more maybe technical questions for you, but I think that's all the time we have for the live Q&A. Great presentation.
Thanks. My pleasure. Thank you. A couple in the chat that I'll answer to now that I can focus on this.
All right. Thanks for being on the event.
Folks in the chat, give me a second. No, my pleasure.
Okay. A great presentation by Pure Storage and their partner, CISCO. For more information, check out the Handouts tab right there in your console. And, of course, you can always visit the Pure Storage website to learn more about the FlashStack solution. All right. Most of you have answered the poll question on the screen. Let me share the results with you. It looks like 24% of you work in an IT department that have more than 100 people. 22% have between 11 and 24. All the way down to 6%, which is a one-person IT shop. Thank you for answering that poll question. I'm going to pop up the next question on the screen there. That is, how many people work at your company? And while I do that, I'm going to announce our first Amazon $500 gift card winner. That gift card is going out to Edward Poshkus. Edward Poshkus from California. Congratulations, Edward. We have 2 more gift cards to give away, so make sure you stay tuned for those prize giveaways. So if you haven't answered the poll, now is the time to get it in because I am sharing the results with you. So it says here 24% of you work at a company between 100 and 500 employees. 15% are 10,000 plus employees, and a real good representation of all other sizes of organizations represented on the event. So thank you for answering that poll. We've got a few more polls throughout the event. But now it's my pleasure to introduce Mr. Mike Kaponen. He is a Senior Director of Solutions Marketing at Pivot3. Mike, are you with me?
I am indeed.
Thanks for being on. Take it away, Mike.
No, thanks for having me on the EcoCast today, and thanks for everyone who is in attendance. I'm Mike Kaponen. I'm a Senior Director of Product and Solutions Marketing here at Pivot3. And for those of you who aren't familiar with Pivot3, Pivot3 is a provider of hyperconverged infrastructure solutions. We've actually been providing hyperconverged infrastructure solutions for over 12 years now. Actually before the industry even coined that term, hyperconverged infrastructure. We've got systems installed, all over the world in 63 plus countries, and we're actually, unique in the hyperconverged provider space in that as a company, we started out providing hyperconverged infrastructure solutions for the video surveillance and security space, where there was a need for really high, ingest performance of that, unique video workload type. Those organizations needed highly resilient storage because they needed to be able to have, access to video, where and when they needed it, and then also needed an infrastructure that was highly performant, from an ingest standpoint, because the quality of the video, needed to be precise, such that a frame wasn't dropped, right when the license plate appeared or the face appeared that you needed to be able to recognize. And then after establishing a strong presence there, then we started to turn our sights to, optimizing the hyperconverged infrastructure, software stack and solutions, around meeting the needs of traditional data center sort of use cases. So when you look at, what we've been innovating in and are known to innovate in, it's, software-defined storage platform, which is, of course, what Hyperconverged is based upon. We have a very efficient and high-performance way we do data protection with a patented implementation of erasure coding that we've been doing since day one. And then in the session today, I'm going to spend a bit of my time, talking about our policy-based approach to management that we apply to performance, data protection, and security, that automates and simplifies the way you automate or way you manage those data services on the hyperconverged solution. And then we were an early innovator in using PCIe flash and NVMe flash in our architecture, and actually optimizing the data path around it and optimizing the software stack to make efficient and effective use of it. And if you keep track of things like Gartner Magic Quadrant and Forrester Wave and such, you'll see us recognized as in the top tier of hyperconverged vendors on those industry analyst reports. And IHS is an industry analyst that focuses specifically on the video surveillance storage space, and we're actually recognized as the #2 provider worldwide of storage or infrastructure solutions for video surveillance. So just a little bit about us there. Now, I know this EcoCast, hyperconverged infrastructure was billed as one of the featured topics here. So my assumption is, folks that are listening in, you've either implemented hyperconverged infrastructures or are considering it. So you may all know what hyperconverged infrastructure is, and so I'll just touch briefly on this. Hyperconverged infrastructure is a way to take and collapse or mash together what were traditionally purchased separately, being a SAN or a NAS system, your servers where you run virtualized applications, and then your storage network. It's the collapsing of all three of those into a appliance sort of model, where the appliance runs your virtualized applications, and so the appliance has a hypervisor on it. In our case, that's VMware vSphere, but then those appliances also contribute storage to the overall aggregate storage pool. So you deploy a cluster of these appliances, and that cluster of appliances now acts as your virtualized server environment, as well as your shared storage pool. And if we've got folks on the phone that have already implemented hyperconverged infrastructure, you're certainly not alone. What I was going to mention was that according to Gartner, hyperconverged infrastructure is the fastest growing infrastructure type within the data center space. You see the stat below here, 48% compound annual growth rate, 2016 through 2021. And as part of that forecast, Gartner states that by 2019, more than 50% of the storage capacity installed in enterprise data centers will be deployed with software-defined storage or hyperconverged infrastructure. So this is a rapidly growing type of infrastructure that companies such as yourselves are deploying. And why is that? This is some research that was done by a company called Technology Business Research. They do a twice-a-year survey of companies who are deploying hyperconverged infrastructures and ask them a whole bunch of questions in terms of why are they looking to hyperconverged infrastructure, what benefits are they getting, what workloads are they running, all sorts of those things. And as you can see from scanning the reasons here for companies purchasing hyperconverged infrastructure, you see that a lot of it is around simplifying operations by reducing cost and making management easier. And companies are looking to replace what they deem to be costly and complex legacy infrastructures with next generation sort of technology. So it's all about simplicity, agility, lowering CapEx and OpEx, the reasons people are moving to hyperconverge. And so time for a survey here that the folks from ActualTech Media have been nice enough to work with me on. I thought this would be a good place to say, what was, if you've implemented hyperconverge, or what will be, if you're looking at hyperconverge, what's going to be your most important selection criteria, around adopting hyperconverged infrastructure. So I thought this might be an interesting way to start out the session here, just to see what people consider the most important criteria in implementing hyperconverged.
Yeah, I'm interested to see the results of this, Mike. I know it's going to be tough to choose just your top three, because in IT, of course, we want it all, right? But let's see what this turns up with.
Yeah, thanks for reminding people that they can pick three here. Okay, very interesting.
All right.
I love these real-time polls in these sessions. They're so informative. So thanks, everybody, for doing this for us.
Yeah, so it looks like most of the audience has voted. Is it okay to go ahead and share the results, Mike?
Yes, please do.
All right. So what do you think there, Mike?
Boy, that's certainly consistent, with what I've seen in other surveys and also in, conversations with our customers. Performance, tops the list, and I'm going to comment on that here next. Efficiency, storage utilization, no surprise. Resilience, and then scalability. No, integration with existing services. The surprising one, I think that vendors don't consider enough, is that one that's got 19%. Integration with existing servers or storage, because when you bring something new in, like Hyperconverged, you don't necessarily want to sweep the floor of what you've invested in previously. It'd be nice to be able to use that Hyperconverged solution in conjunction with your existing servers and storage. So that's interesting to see as well. Okay, well, good, thanks.
Yeah, absolutely. Cool results. Take it away.
All right. So given the benefits that I shared with you there in terms of what companies are getting out of hyperconverged infrastructures, what we hear in conversations with customers is that now the companies have got a taste on the benefits of hyperconverged, they want more. And what they want to do in particular is consolidate multiple mixed application workloads, including their mission critical ones that may be in particular performance and latency sensitive. They want to consolidate more application workloads on hyperconverged to get rid of silos of infrastructure and also drive down their costs by supporting more applications on that hyperconverged infrastructure. And in order to make this transition, and this is why the survey results are kind of interesting, when we ask customers, hey, what do you need to know to make the leap and move from your traditional way of doing things to hyperconverged, what we hear a lot is, well, I need to ensure that it's going to perform for my applications and use cases. And I'd like to be confident that I'm going to get better performance than what I had before. So this was interesting to see performance come up as number one. And then this, can I confidently support multiple mixed application workloads? Hyperconverged is supposed to be all about simplicity, so I need to be ensured that I've got tools to make it simple to manage, efficient and predictably scale. Scalability came up, I think, as one of our top four things there. And then, does it have all the normal data services and management tools, that I had in my SAN environment, that I've got in my virtualized server environment. And so this is what customers ask of us as we start to engage in conversations with them about learning what we do in hyperconverged. So from a Pivot 3 standpoint, in particular, we see our differentiation and value, being all around performance, scale, and efficiency. And I'm going to touch on these things here subsequently, so I won't dwell on them now. But all of that is then under the wrapper of a high degree of intelligence and automation. And you'll hear me refer to something that I call the intelligence engine. Pivot 3 has a lot of intellectual property and innovation in policy-based management and automated resource allocation to ensure that we deliver the proper level of performance. It's easy to scale, and then we make efficient use of both the compute and the storage resources that you're deploying. So let me kind of dive into a few examples of this now. So why do we say we're architected for performance? Our architecture is we refer to as a multi-tier distributed architecture, and so we have hyperconverged nodes that make use of multiple storage media types from hard drives in our hybrids, SSDs in our hybrid as a caching tier, and then SSDs obviously in our all flash tiers. And then we were an early innovator in the use of NVMe flash as not just a read-write caching tier, but actually a persistent tier of storage that's under control of our policy-based management engine. So your mission-critical applications, that need the low latency of that NVMe flash are going to live a lot up in that NVMe flash, based upon the policy we assigned, and then memory as well. So we have this, multi-tier architecture, that's designed to deliver, the highest levels of performance and lowest latencies, so you can do this consolidation of multiple applications, including mission-critical ones. And then what happens within this cluster is all of the resources within all of the nodes of that cluster are pooled together. So any VM, regardless of the node that it runs on, gets the benefit of all of the disks in that aggregate pool. So if you have a cluster of 3 nodes, in this case, and each of those nodes has 12 disks, each VM, regardless of what node that it runs on, gets the performance benefits of its data being written across 36 disks, and also gets the aggregate benefit of all of the cache, all of the memory that's in that aggregate pool of resources. So that's what we mean when we say we've got a distributed architecture and then multi-tier with these multiple storage media types. And so just an example, I picked one particular workload here to illustrate what this results in from a performance advantage standpoint. So I picked VDI, but we've got other examples of transactional workloads and Splunk and things of that nature that prove this out. But as you can see here, in comparing the results that we get for task and knowledge and power users, using Login VSI, which is the tool that all of us storage and hyperconverged vendors use to benchmark, how many VDI users we can support per node, like node types in terms of CPU, RAM, et cetera. So it is a good apples to apples sort of comparison, as comparing to numbers that other companies posted on Login VSI's site based upon their use of Login VSI as well. So we do indeed see this playing out in publicly published benchmarks in terms of how we can deliver higher performance, higher density per node, and that results in needing to purchase fewer nodes to do the same task. So let me segue now and talk a little bit about this intelligence engine that I referred to earlier. The intelligence engine encompasses utilizing policy-based management to take and automate achieving SLAs that you set for different application workloads that you're going to run on the system. And so we do this both for performance, data protection, security, meaning data at rest encryption, and then data placement. And then we also have, under the umbrella of this intelligence engine, monitoring and analytics that takes and assesses the health and the performance of the system, feeds back to our support cloud, lots of analytics on the system, and then feeds to the user daily reports on different indicators of the health, the performance of the system, and then our support team makes proactive calls out to users to point out things as well. So let me just step through a couple of examples of this. But first, this slide, Gartner has actually pointed out that where the real innovation needs to come in hyperconverged infrastructure systems and solutions next is putting more intelligence and AI and machine learning into systems to take and simplify the system administration sort of tasks and ensure that the resources get delivered to the most important applications that you're running on hyperconverged. So I put these quotes from Gartner up there that were pulled out of 3 different reports that they published this last year, just to kind of point out that we're not alone at Pivot 3 thinking there's value in putting more intelligence into the system to take and simplify your lives from a system administration standpoint. It's echoed by one of the leading analysts out there. So let's see how this plays itself out in the area of performance. And so, what you do from a performance standpoint is you can take and assign 5 predefined performance policies to particular application workloads, meaning the storage volumes or data stores associated with them. Policy 1 being the most performant, policy 5 being the least performant, and that specifies an IOPS and a throughput floor and a not to exceed latency target. So you as the user now have said, what applications are more important than others. So if there are times of resource contention, the system will take and throttle back resources to what you designated as the lower important applications to ensure that the ones that are in policy 1, which is mission critical, get guaranteed access to resources, and so they'll never drop below their IOPS and throughput floor and never exceed their latency target. So it really simplifies ensuring that in particular your most mission critical applications get the performance they need and deliver consistent, predictable performance to end users and customers. And so this screenshot just kind of shows that it's a simple matter, in the UI of picking, what policy number you want to take and assign to that volume. That policy can be changed, on the fly, or you can actually schedule that policy to be changed at a predetermined point in time, and that's what the screenshot on the right shows there. From a data protection standpoint, I mentioned we use erasure coding. Erasure coding is a highly efficient way to do data protection. You can see here that if you needed 385 terabytes of raw storage, you could, if you needed 360 terabytes of usable storage, using one of the erasure coding levels, you would only have to take and purchase 385 raw terabytes of capacity to get 365 terabytes usable. And the way most hyperconverged infrastructure vendors provide resiliency is to take and replicate data across the nodes in the cluster to be able to take and survive an entire node failure. But there you're cutting your usable capacity in half or maybe up to a third. And so this is how we deliver really high storage utilization. And then we use the same approach of policy-based management for data at rest encryption. So if you want to encrypt a volume, you just take and select, I want to encrypt that volume, and then it automatically generates keys to that volume as well. And everything we do in this case is FIPS compliant as well. And we also use AES 256 from a encryption algorithm design standpoint, so it's essentially military-grade data at rest encryption. Scalability, I'm going to build this out real quick because I know I'm running short on time, and I do apologize for flying through a lot of information quick. I'm just trying to kind of whet your appetite here and come chat to us to learn more. But from a scalability standpoint, you can scale hyperconverged nodes, or scale by adding hyperconverged nodes, nodes that run virtualized applications and contribute storage to the pool, or you can scale by just adding storage-only nodes, compute nodes, and then we have GPU-enabled nodes as well. So it gives you a lot of flexibility as to the way you scale. And then the portfolio is built out with small form factor 1U appliances for edge, robo, micro data center type environments. Appliances that are 2U form factor. You can see the capacity ranges from 4 terabytes to 288 terabytes in a single node. We find that to be highly effective in large-scale IoT type environments. And then a wide range of CPU types, RAM amounts, all that sort of thing. And then you can scale up by adding nodes to a cluster as is depicted, or manage multiple clusters under a single management console, or what we refer to as a single domain. So lots of flexibility as the way you can scale out your environment depending upon your needs. We sell into and deploy in all these type of solution environments. VDI, a lot of our customers are quote modernizing their data center by moving away from legacy 3-tier architectures and to hyperconverged and supporting multiple mixed application workloads, and doing so, setting up BCDR sites based upon hyperconverged, because it winds up being a simple way to deploy that, easy to scale. We have customers running all sorts of enterprise apps, big data analytics, from SQL, Oracle, SAP, Splunk, all those sorts of things on us as well. And we work with a broad range of technology alliance partners to do that. And I'm sure you see on this list, lots of companies that you have in your shops, whether it's backup and recovery vendors, BCDR vendors, VDI vendors, et cetera. And at the end of the day, what we're trying to do for you, with the performance we deliver, and this simplified management through this intelligence engine, is we're trying to lower your total cost of ownership, by helping you support, more workloads on less infrastructure, give you predictable, consistent performance, with this policy-based way to ensure that the resources in the system, get assigned to applications that are most important to you. Lower your OpEx, your system administration costs, through this simple policy-based management approach. And then from the way we deliver, efficient data protection and resilience, give you a mechanism where you don't have to compromise availability for performance versus storage utilization, essentially give you all of those, through this distributed architecture, through our patented way to do erasure coding. So, I threw out a lot of technology terms and how we do this, but at the end of the day, this is what we're trying to do for all of you on the phone here is, lower OpEx, CapEx, make sure you're delivering the right business services to your users and keeping everybody, happy and productive. So that's it. Gosh, I need to take a breath now. I think I put together a longer slide deck than I should have, so I kind of apologize for that, but hopefully that gave you a quick overview of what you can do with Hyperconverged and some of the differentiation that Pivot 3 delivers. So I'd love to have you contact us for more information. Just send an email to sales@pivot3.com. Visit our website at pivot3.com, and love to engage with you and have you learn a little bit more about what Pivot 3 could do based upon what your business situation is.
Yeah, great presentation, Mike. I'd rather have too much information than not enough. So that was really good. I appreciate you, trying to educate us as much as possible. Let me go ahead and pop up a poll question here for the audience. I'm going to leave that on the screen while we do some Q&A. We do have some questions incoming here from the audience. So, Mike, Brad here, he's asking, are the Pivot 3 solution cost-effective for small businesses such as manufacturing?
Yeah, it depends. Good question. It depends on what you mean by small business. I mean, we have mid-sized, companies, of say, 500, users using Pivot 3. Manufacturing is actually one of the areas we do a fair amount of business with, both in our video surveillance and security line, as well as just core data center type applications. So, if you're in an environment now where you've got, 3, 4, 5 physical servers supporting, 30 some virtualized applications, and you've got more than, say, 12, 15 terabytes of storage, that's a place where we can deliver you a cost-effective solution, as a starting point.
Okay. And then another question here, what's the minimum number of nodes you need? And with a number of different hyperconvergence options out there, what makes Pivot 3 stand out?
Okay. Yeah, boy, great questions as well. You can actually start with just a single node, and we do have customers who do that at a remote office or an edge environment. The thing about a single node, is you're relying on just RAID in that node, from a resilience standpoint. So if the environment really, demands high availability, we recommend 3 nodes, because then you can lose an entire node out of those 3, and still have volumes online and available. And you could actually lose up to 5 simultaneous drives out of those 3 nodes too, and still be online and available. So if you need high availability, you really need to start with 3 nodes. And then what makes Pivot 3 different? A lot of it is in the intelligence and automation, from this intelligence engine. The policy-based management that delivers performance quality of service, data protection quality of service. Other hyperconverged vendors will claim to do quality of service, but we actually do it more elegantly, more easily. Performance, from the way we utilize NVMe flash, and then the efficient resilience, because we from day one have used this patented implementation of erasure coding. We can provide you a solution to do your job in fewer, and you end up purchasing less raw storage to do that, because we just deliver much higher degrees of effective storage utilization with our erasure coding, combined with we do compression on top of that as well.
Okay. And there's a lot of good questions coming in, Mike, for you that you can answer electronically. But I think we have time for just one more, and that is, how do people get started with Pivot 3? Like, what's the first step usually?
Usually the first step is just to engage, with one of our solution architects or one of our channel partners, and have a discussion around, what your situation is, what your needs are, what type of application requirements you've got, et cetera, so we can just assess, are we right for you, and describe what we can do for your particular situation. So, drop us an email at that sales@pivot3.com, and that would start the process.
Okay. Excellent. Excellent. Well, thanks so much for being on today. Great presentation, Mike.
Thank you, and I will get to the questions that came in online now as well.
Awesome. For more information on the Pivot 3 solution, visit pivot3.com. Also check out the handout that's there in your audience console for download that covers the Pivot 3 HCI solution. If you haven't answered the poll question on the screen, now's the time to do it. I'm sharing the results with you. And let's take a look at this. So 26% today on the event are from technology companies, 17% manufacturing. That's quite high. That's interesting. 7% healthcare, 6% state, 6% local government, 7% other. Interesting to know what those might be. 6% telecom, 7% finance and banking. Thank you, everyone who voted in that poll question. Very, very interesting to see organizations of all different verticals represented on the event today. And before I go on, I should announce our second Amazon $500 gift card winner. That is going out to Kyle Thompson from Washington. Congratulations, Kyle Thompson. We've got one more gift card to give away at the end of the event, so stay tuned for that. And with that, it's my pleasure to introduce Patrice Bourne, who is a principal sales engineer at Robin. Patrice, are you with me?
Yes, I am. Good afternoon.
Good afternoon. Thanks for being on the event. Take it away.
Okay, thank you. So we are going to talk about what Robin Systems does today, and more precisely, we're going to look into our hyperconverged Kubernetes platform to run big data databases and AI and machine learning workloads. And I'm going to start by having a quick overview of what a traditional HCI architecture looks like that probably everybody listening has some kind of experience with, where you have these x86 standard commodity hardware servers where you're going to run some kind of hypervisor, pick your favorite, and this hypervisor is going to allow the system to run multiple virtual machines and thus multiple applications in those virtual machines directly on this hardware. What we do, which is different, is we do not use any kind of hypervisor, and we do not use virtual machines. What we're going to do is use the exact same x86 commodity hardware that everybody knows, and we're going to install a Linux operating system directly on top of those machines. And those machines are going to be then connected in a cluster running the Robin software. And what this Robin software does is it's going to use under the cover the standard Kubernetes that you may have heard of to orchestrate the different containers that we're going to use. And we're going to also add features that don't exist in Kubernetes. More precisely, we're going to add our software-defined storage layer, which allows us to do things like being able to run stateful applications on top of just stateless. So for those of you who may not know why this is relevant, if you use standard Kubernetes with Docker, for instance, you are going to have to run or rebuild your applications to be stateless, meaning that they can be restarted without having to remember a given state of when they were shut down or came down. So obviously, all the typical applications that have been written over the years, or decades, I should say, were built way before the concept of stateless was actually being pushed by Kubernetes and Docker. And everything that you've had built over the decades, now you are limited because you cannot run them directly on Docker and Kubernetes. However, with Robin, we can do that. I'm going to explain in a couple of slides how we do it. But we're going to be able to actually offer persistent storage automatically, nothing to configure, automatically to all the different containers running on the nodes. And those containers are going to run different applications. And those applications are mapped, or more precisely run, inside pods that Kubernetes is going to manage under our control. The other piece we add to Kubernetes is on the network. And we're going to provide a standardized way of handling the network so that when you spin up or you ask the system to spin up a new container or a set of containers for a given application, we're going to rewire all the IP stack underneath, and we're going to guarantee that even if a container gets restarted and gets moved to another host to be run on, we're going to provide the exact same IP address, and we're going to provide the exact same node name, and all the IP stack is going to be rewired exactly the same. We also do that on the storage layer, which means we can run with Robin stateful applications like database engines or Hadoop. Next slide. So we're using Kubernetes, as I said, but on the next slide, we're going to see what does that mean. So what if your users could bring up an entire cluster in minutes, not weeks? And the way we do this is by providing a user interface where an end user can directly connect to and say, I want to spin up a MySQL database. Couple clicks, boom, you have a MySQL database running. Or I need to spin up a full-blown Hadoop cluster. Couple clicks, you get your Hadoop cluster. Or I need to create an Oracle database because I want to test something. Boom, in a few minutes, you have an Oracle database ready to use. All these applications are going to be run in containers. And if it's a distributed application that requires many services, like a typical Hadoop setup, we're going to create multiple containers. And we're going to distribute those containers on the different machines that constitute the Robin cluster. We're also going to rewire the storage and the network, as I said, and we're going to reconfigure everything so that all the different containers are aware of the other containers running the other services they need, and everything now runs in containers. So there's no virtual machine, as I said, there's no hypervisor, and this allows us to do a few things that are really powerful, like giving a user interface to an end user who does not need to know all the details of the low-level plumbing of how you put these things together on servers. It's just a UI. What we also offer is the capacity to have clusters that may be entirely in the cloud, entirely on premises, or spanning in the cloud on premises. And you can control, because we control the storage layer, you can control the data, and you can also ask the data to be replicated, for instance, from your machines on-prem to machines in the cloud. And then you can ask the system, when you need to move a container from nodes on-prem where it's running to nodes in the cloud where you want to run next. So this allows you to decide where you want to run a given workload. This also allows you to have a multi-cloud strategy if you want to do that. If you want to have more than one cloud provider, you put this extra layer on top called Robin, and you become cloud agnostic. And you can also provide typical lifecycle management for all your applications with one click. For instance, I need to scale up. So I'm running a Hadoop cluster. I want to scale up and add more HDFS data nodes. Just one click, you say I need another 5, another 10, another 1, another 21. And it's going to create new containers. It's going to configure them to run the data node code, and they're going to join the existing HDFS cluster that's already running inside your containers. We also provide things like being able to take a snapshot of an entire application. So that means snapshot of the data, snapshot of the network layer, snapshot of how the containers are configured, and we also provide, by using the snapshots, features like testing an upgrade. So I want to test an upgrade, but I'm not sure what's going to happen, so I want to make sure I'm not going to break something. You can take a snapshot, ask the system to test the upgrade. So it's going to test the upgrade on new containers that are rewired read-only to the existing data with blocks being created on Modify, but it's going to test the upgrade in a copy on different containers of the running application. Depending on what happens, you're happy with it or you're not, you apply the upgrade or you roll back. We can also do these clones, thin clones. So what happens is we ask the system to take a snapshot and we say create a clone because I want to do something else, but I don't want to damage the existing system that users might be working with. It's going to create a new set of containers that are going to reuse the exact same data as I was explaining, but you don't upgrade this time. You just do, it's another application, which is a clone of the existing application. This allows you to do anything you want without any chance of damaging the running cluster you may have already. So we do all this on top of the standard Kubernetes that we also expose. So if you have some Kubernetes knowledge in-house, you can reuse that knowledge. So we usually ask, but what if I wanted to do this by myself? Well, that's potentially something you could try. However, like everything else, there's the potential for a difference between the desired result and what you actually end up with. And that's why we provide all these features and all these extensions on top of Kubernetes. And again, I want to emphasize, we do not modify Kubernetes under the covers. We reuse the standard Kubernetes, unmodified, 100% unmodified on purpose. We simply add next to Kubernetes pieces that allow us to do what we do. This is very important because sometimes we get the question, but what if you modify Kubernetes? Who's going to support the modified Kubernetes? Well, we're not modifying it. So anything that the Kubernetes community is going to do and put out there, we're going to have because we reuse exactly the same Kubernetes under the covers. However, we add these extra pieces next to it that don't exist in the Kubernetes project. So what is Robin? Robin is a hyperconverged Kubernetes platform to run all these workloads. So big data, I talked a little bit about that. We can also obviously run Spark. Databases, because we can run stateful applications, because we control the network and the storage layer. The database, by definition, is a stateful application. It's its job to keep track of the state of the data you put into it. So we can run any kind of database engine you can think of, all the oracles in the world, Mongo, Cassandra, MySQL, Postgres, you name it, we can run those. And we can also run AI and machine learning workloads, obviously. And we also can run, if you want to, an existing application that you wrote in-house 5, 10 years ago. And the way we do this is by creating a Docker image from your servers the way they should be installed with your application and all the PCs. And we're going to set up that new Docker image in your own local Docker image repository, so you can run your private Docker Hub, Artifactory, whatever you want to use, so that only you have access to that new image, and you can reuse that as an input to the system so that you can now containerize without having to rewrite the whole thing. You can containerize an existing stateful application that you wrote 10 years ago. And you can put it into containers like everything else, and now it's just another one container running on top of the Robin platform. So here's a couple, actually more than a couple, but a few data points of what we currently have with existing customers. So just to give an idea of the kind of performance we get, and we get that kind of performance because we don't have a hypervisor, right? We write to disk directly. We do not use some kind of file system in between. We directly access the disks at the block level. And that allows us to have really, really good performance for tools like Kibana, Kafka, especially Kafka that needs performance to be able to do its job streaming. And that allows us to run 11 billion security events ingested and analyzed a day for that specific customer. We also have customers storing 6 petabytes of data directly in a Robin cluster. And we also have customers running Oracle RAC databases. I forgot to mention that, but we can also run Oracle RAC on a Robin cluster. So we have a customer running 400 Oracle RAC databases right now on Robin. So quickly, what's the software stack? So at the core, we put Kubernetes, standard Kubernetes, unmodified. I know I'm repeating myself, but this is very important because we don't want ever to modify Kubernetes because we don't want to own whatever change we may introduce into a standard Kubernetes. We want to reuse the exact same standard open source Kubernetes on in the community. We add a layer to manage the storage. So what that means is we intercept all the reads and writes from the containers themselves, and we are going to redirect those either to local storage devices, SSDs or spinners, your choice, or to remote storage if you allow it to go remote. And obviously we're going to have to push the data over the wire in between the nodes. That's obviously obvious. But this allows us to override all the different mount points and volumes that are configured for a given container. So including especially the root file system, the one mounted on Slash on Unix. And this way we can guarantee that we can run stateful applications, because when we restart, or more precisely when we ask Kubernetes to restart a pod that contains a container that runs whatever application you might be running, we're going to rewire the entire storage layer. So all the data that was stored on disk is actually visible when you reboot the container. And this is fundamental to being able to run stateful applications. The other piece that we're adding is this virtual networking layer. And today we support either Open vSwitch or Calico. It's your choice. If you use Open vSwitch, you're going to use real IP addresses, meaning that they are visible and routable from the outside of your cluster, from a client, client application, client machine, whatever that is. You can use the IP address of the container if you decide to go with OVS to wire those IP addresses to the containers. And if you go with Calico, you're going to have an overlay network that is going to use its own range of IPs that are not visible from outside of the cluster. And you're going to have to do the port mapping slash find the IP address of the host running my container thing, like everybody else with Calico, with one difference. The Robin software guarantees that the port mapping is going to stay exactly the same for the entire lifetime of an existing application, thus a container, which means that if you're running, for instance, a Postgres database that wants to listen on 5432 and it gets mapped to 20001, it doesn't matter what node that Postgres container runs on, even if it gets rescheduled on another host, we're going to guarantee that its port mapping will still be 20001. The only thing that's going to change in this case is going to be the IP address or the name of the host running the container. And then at the top, we have our application workflow manager, which is basically the Robin code that glues all these pieces together. And that also provides a UI, which is web-based, so use your standard browser. And we also provide what we call bundles. And those bundles allow us to offer an app store-like experience where you have the choice of all the different applications that your administrator has given you access to. And you can select, I want to run a Cloudera cluster, I want to run a MySQL, I want to run a MongoDB with 5 shards, I want to run something else. You click on it, and you get presented with a config page with a bunch of default values already entered for you. You can override them if you want to, or you can accept and simply say deploy. And we run on bare metal, obviously. We can also run in virtual machines if you want to do that. And we can run in the cloud with the 3 main providers out there. So what's this App Store experience I'm talking about? So this is a screenshot of what it looks like. You select whatever application you want to run with, and then you're going to be presented, in this case this is Hortonworks, you're going to be presented with a configuration page where on the left side you have all the different services that you can turn on and off depending on what you want to do. And if you turn them on, you're going to say how many instances you want, i.e. how many nodes, which are going to be mapped, each one to a separate container. And you're going to define how many resources you give to these nodes, how many CPU cores, how much memory. And then for the storage portion, you're going to say these different volumes pre-configured in the bundle itself. The bundle is basically a YAML file with a bunch of scripts. You're going to say, I want to give it 20 gigs, 50 gigs, 200 gigs, 500 gigs, whatever it makes sense. You're going to say if I want SSDs or HDDs. Then when it comes to the parameters, you can also, depending on what it is, these parameters can be completely different. If you're dealing with a MySQL database, this is going to be, give me the password that you want me to set up by default for the admin, MySQL admin. If this is a Postgres, something equivalent, maybe some environment variables you want to pass. Whatever makes sense for whatever service or application you're about to deploy. And then we have placement rules. So those placement rules allow us to define affinity and anti-affinity rules where you can say, I want this to happen in terms of placement, or I don't want this to happen in terms of placement. So you can do things like Zookeeper, do not run all my Zookeeper containers on the same host or on the same rack, because I know that if I lose the node, if I lose the rack, I'm going to have a problem if all my Zookeepers are gone. So you can this way define what you want or don't want so that the system knows. And then at the very top, obviously, you need to give it a name. The resource pool is just a way for you, for an admin, to group node, hosts into logical pools. So because we also have the concept of multi-tenancy, you can say tenant 1, you're only allowed to deploy on nodes belonging to resource pool number 1. Tenant 2, you're only allowed to deploy on nodes belonging to resource pool number 2. So depending on how you want to organize your machines, your tenants, who has access to what, you can control this with resource pools. The IP subnet is actually allowing us to select an IP pool. So we're going to tell, an admin is going to define those pools. And we're going to tell the system, when you deploy those containers and you need to give them an IP address, grab those IP addresses from that pool. And in the config page, which I don't have here, your admin is going to say this IP pool uses Calico, this IP pool uses OVS, and those are the ranges that this IP pool is allowed to use. And once those are configured, they show up on that page. And same thing, your admin can say, tenant 1, you're only allowed to use these IP pools. Tenant 2, you're only allowed to use those other IP pools. Or maybe you can share. So once you are satisfied with all the different parameters, you can ask the system to deploy, and it's going to do all the job for you. So it's going to first make sure it has the resources on the hardware that you gave to it to actually grab whatever it is that you want allocated in terms of memory, in terms of CPU cores. And then it's going to solve the puzzle of those placement rules that you gave to it by saying, I want this, I don't want that. And if there is a solution, it's going to find a solution, and then it's going to start deploying and running scripts under the covers to pre-configure and pre-wire everything so that at the end, whatever application you ask for is ready for use. So this is just a quick zoom in of what this left column is about. As you can see, some services obviously are must-have, so there's not an option to turn them off, like a data node. You need some HDFS. Zookeeper is also, although it's not showing here, is also mandatory, so you cannot turn it off. But other than that, Hive, you may or may not use it, so you can turn it off if you want to. Then here, it's showing you exactly what it's telling you, which is that you can specify how many resources, how many instances you want to give to your service. And those placement rules allow you to define, I want this, I don't want that in terms of placement. And this allows us to provide this App Store experience where end users can get access to a brand new application on their own, thus liberating your sysadmin, your DBAs, and whoever is usually taking care of installing software, configuring, finding a server, I need to wire the network and to ask IP addresses from my network guys, etc. You can now give access to your end users within control, within limits, because you can say you can do this, you can do that. We have the concept of multi-tenant. And that allows us to provide a ton of value because now you can consolidate workloads, so you use your hardware a lot better. You remove all the limitations in terms of time to get to something up and running. Because now with the UI, you get a full-blown application ready to use in minutes instead of potentially weeks. And finally, all your sysadmins, your DBAs, whoever is taking care of that today, you can now free their time up for other tasks where they can focus on doing other things other than just copying an Oracle database or setting up yet another Oracle database or setting up another Hadoop test cluster for someone to run something for a week, and then you take it down. You just give access to your end users and they can do this on their own. So lifecycle management is once the whole thing is set up and is running, what can I do? Well, you can do a few things directly in the UI without having to ask your admins to do it. You can scale up and down, meaning create new containers or remove existing containers. And we're doing it the right way, meaning that we spin up the containers, obviously, but we also run scripts to let the new containers know that they need to join an existing cluster of something, for instance, so that the whole application is aware that now it has more resources. You can also, so that was for scaling out. You can also scale up an existing container. So if you know that your Hive metastore that you store in MySQL is a bit short on CPU and memory because there's a lot of demand, you can, on a running container, say, give it more memory or give it more CPU cores, and we're just going to do that directly from the UI. You can also control the quality of service. So because we intercept all the reads and writes, we can cap the I/O per second a given container is consuming for a given volume. So this way we can solve the noisy neighbor problem that you can get potentially when you run multiple independent applications in independent containers on the same machines. Virtual or physical, doesn't matter. If one of these starts grabbing all the I/O resources, everybody else is going to starve. We can control that because, as I said, we intercept reads and writes so we can count them, so we can put a cap. So those are some of the screenshots that show what you can do. You can also create a schedule to take snapshots of an application if you want to do that for whatever purpose, as a way to be able to go back in time if something wrong happens. You can also have upgrading bundles where the bundle itself is containing all the instructions to upgrade a running application of version X to version X+1, for instance. And you can test those upgrades using the cloning feature I told you about. So the benefits, depending on your profile, why would you want to use Robin? to run your different applications in containers. If you are talking about operations, you're going to simplify everything. And you're going to be able to increase the utilization rate of your hardware, obviously, because you consolidate. You also can guarantee SLAs and uptime, because we also have a lot of HA and DR mechanisms I didn't look into today, where you can guarantee that if something goes down, it's going to be rescheduled. Even if the entire node where those containers were running went offline for whatever reason, motherboard just fried, they're going to be rescheduled onto another node, but directly, automatically by the system. If you ask for the data to be replicated by Robin, or you were running an application that knows how to do it on its own, like HDFS, then we know we have a copy of the data somewhere else. So when we reschedule the pods, we're going to rewire the storage to the copy of the data, so this way they can be restarted and be happy and find everything they were expecting on disk, and they can be running again. And obviously, it's a very profound move right now that's happening in the market, where everybody's moving to containers because of all these value-added features, especially compared to virtual machines, which is a concept that's 20 years old, where you now have everything in containers, on-prem, in the cloud, and you just move stuff around by asking the system, move this to that node or move this to that other node. And if you work in development, and you want to apply all these agile concepts, now you can fully have a fully automated way of doing your all CI/CD pipeline directly by using, I didn't tell you about that, but we also offer a REST API or command line. So if you want to script, if you want to use the REST API, we also provide access to kubectl, because we still have standard Kubernetes under the covers. We also provide access to Helm charts if you want to use those. And you can fully automate the entire process. And we have a customer that's doing just that. They automated the entire thing. So every time a developer commits something into their local GitHub, it triggers, obviously, a build, automated build. And then before they run the different testing, what they do is they call Robin and ask Robin, hey, deploy these containers for this application. I'm going to push this build into these containers, and I'm going to run my test, my automated test, directly on those containers running my new build, and then I can report on the results. Fully automated. And that's it for today. So thank you for listening to me. So maybe we have some time for some questions.
Yeah, we sure do. Yeah, great presentation, Patrice. Very cool stuff. I'm going to go ahead and pop up this poll question for the audience and just leave that up there while we do some Q&A. The question is, what's your time frame to refresh or update your data center, compute, or storage infrastructure? So, Patrice, one question here Richard is asking, is there a stateful API for the Robin system solution?
Yes, we provide different ways of interacting with the system. You can, as I said, use the UI, which is typically how people start because it's easy. And if you want to script something or automate, obviously you need access to the system directly. So we provide a command line, so a CLI, your typical CLI with all the options in the UI are accessible directly from CLI. So if you want to run a shell script, you can also use our REST API if you want to do that, same thing. And by the way, the UI and the CLI both call the REST API under the covers. So anything you see in the CLI or anything you see in the UI, this is actually converted to a REST API call, which means that the REST API is actually the right way to interface with our system if you want to get into the low level of how the thing is orchestrating. The other two entry points we provide are kubectl, and if you want to use a Helm chart to deploy something directly on Robin, we can do that too.
Okay, very nice. Another question here, they're asking, can I use the Hyperconverged Robin solution?
Yes, we actually have people who do that specifically because, I'm not going to give names obviously, but there are many, many prospects and customers who love the concept of the cloud, meaning the agility technical agility, obviously, but also business agility, right? You heard that your competition came up with a super cool machine learning way of doing something, and now you need to catch up, and you want to test something quickly, right here, right now. Well, you can obviously spin something up. Problem is, the cloud, people don't want to put that data in the cloud for different reasons, especially if you talk to financial services, insurance companies, anybody who has some kind of very, very potential, very large potential risk associated with being hacked and having data stolen. Everybody is extremely careful before they put their data in the cloud. And so all these people I'm talking about, they are in a situation where they love the concept of the cloud. Spin something up in minutes, scale up, scale down, tear it down, share resources, etc. But at the same time, they don't want, or they cannot. It's legally such a nightmare that the lawyers say, you're not doing that. So what do? They look at building their own private cloud. And we have customers who did just that with Robin, where, well, guess what? You're not going to use the typical cloud that you've heard on different websites. You're going to use our own in-house version of it that's actually using the Robin UI. And we're going to give you access to all these features where you can do what you want within limits, obviously, as I was saying. You can control what your different tenants are doing. And this is how they implement their own private cloud solution.
Very nice. And then another question here, can you run any database engine in containers on Robin?
Yes. So this is a big one. One of the big reasons why people go with Robin instead of trying to use Kubernetes/Docker directly themselves and putting all the glue that we put together over the last 4 years. The typical database engine, by definition, is a stateful application, meaning that, especially if you run something like an Oracle database, if you try to shut down an Oracle database cleanly or not, and then you change the IP address and try to restart it, I guarantee you it's going to start complaining a lot. So you cannot do that, obviously, in containers. We can run an Oracle database in containers because we control the storage, we control the network, we control all the different little pieces in between. So an Oracle database can save its data, and its data is going to be given access, its data files, or even ASM storage if you want to do that. It's going to be given access directly to the spindles like any other block device. And after that, the blocks are stored outside of the container. So if the container needs to be restarted or moved around or whatever, we're going to rewire the storage layer. We're going to rewire the exact same IP stack. And when you restart your Oracle database, for instance, in your container, it's going to just restart because it found all the data it was expecting on disk, and it finds the network config it was expecting. So any kind of database, which are stateful applications, can be run in containers on Robin.
Very nice. And then a final question we probably have time for here is, how do people typically get started with Robin? What's the first step?
So the first step is usually to talk to either someone like me who does the sales engineering, or to talk to one of our sales executives. And we usually start by having maybe a more detailed presentation. We talk about the use case. We talk about the objectives of what people are trying to achieve. And then we also do a demo because we have test clusters, obviously, internally that we can use for demo purposes. And then if everything makes sense for everybody, we usually have a POC that we frame usually around 2-3 weeks. We frame in terms of use cases. We also define exactly what people want to test, what applications they want to test, their success criteria, and we execute on the POC.
Very nice. Very nice. Sounds easy. Well, I think that's all the time we have, but really great, really amazing presentation. Thank you so much for being on the event today, Patrice.
You're welcome.
For more information on Robin Systems, visit robin.io. Also check out the resource that's available for download right there in your audience console. You can learn all about the Robin Systems Hyperconverged Kubernetes solution. And with that, I appreciate everyone answering that poll question that's on the screen. let me announce our final prize winner on today's event. The last Amazon $500 gift card is going out to Richard Miller from Wisconsin. Congratulations to Richard Miller from Wisconsin. If you didn't win today, best of luck on our next event. In fact, we have an event coming up soon. I'll talk about that in just a moment. But first, don't forget to check out our 10 on Tech podcast over in iTunes. You can subscribe and learn about the latest and greatest in enterprise technology with the 10 on Tech podcast. Visit events.actualtechmedia.com to learn about all of our upcoming events and watch past events. In fact, our next event is in 2019. January 17th is the Converged, Hyperconverged, and Composable Infrastructure Integrated Platforms EcoCast event. So if you want to learn more about HCI, Composable, Converged, check out this event, January 17th, 2019. Watch your email inbox for an invitation to that. If you're a potential sponsor of an EcoCast or MegaCast, just email us at sales@actualtechmedia.com, and we would be glad to chat with you about the series of events and how you can sponsor and present. And with that, thank you to everyone out there in the audience who attended today's event. I hope that you learned a lot. I hope that you got all your questions answered. I hope that you enjoyed the event, and I hope to see you on a future event. Have a great day. Bye-bye.